First in a series on how to solve mixed spectra problems, also as done in class. We don't have to, but it's short and sweet, so let's start with the mass spec. And we want to look closely, although even at this scale I can see that right around here, that's where our molecular weight is likely to be. So looking at it now at about page size, you can see we're looking at 97 or 98. There's a little bump there at 98. So I'll note molecular weight is 97, 98, something like that. No need at this point to take any more information from our mass spec. Maybe we'll come back later and look and see how some of these peaks or masses correspond to the structure and fragmentation pattern. But for now, let's move on to the IR. So looking at the infrared spectrum, one thing we can see immediately is there appears to be an OH. So we'll note that, and you got to remember to look in this area too, and there appears to be either a nitrile or an alkyne. It's not very big, the peak, which might be an indication that it's the alkyne. Okay, so that didn't take very long, so now it's time to take a look at the NMR spectrum. And in looking at the NMR spectrum, we can see the integrations are given. And of course these are only ratios, but we'll start out, they're reasonable numbers, so we'll start out taking them at face value. But again, they're only ratios. And so we've got a 3, 2, 1, 1. So we've got 1, 2, 3, 4, 5 different peaks, 5 different kinds of hydrogen in the molecule. And if we look at this, that's a triplet. And looking down here, we see there's a quartet. They go together. They're the only split peaks in the spectrum. So remember, if proton A splits proton B, then proton B splits proton A. So those two have to correspond to hydrogens that are on adjacent atoms in the structure. And then we've also got a singlet, and another singlet, and another singlet. So our triplet integrates for 3, and our quartet integrates for 2. Pretty good indication that's an ethyl group. So let's write that down as a structural feature in our molecule. So we've got that as a structural feature. We've also got a singlet that integrates for 3. There's a good chance that that's a methyl group. We don't know what that methyl group is attached to, but whatever this question mark is, doesn't have a hydrogen on it, or this would not be a singlet. Our IR said we had an OH, so I should probably be seeing that somewhere. I've got 2 singlets, integrate for 1. One of those is our OH. So that's a piece in our puzzle. And then that leaves me with one other hydrogen. Now looking at the region here, that's chemical shift of, say, around 2.5 or something like that. I'm not sure exactly what that is, but I've got another hydrogen somewhere in my structure. So now what we need to do is start putting our pieces together. And the biggest mistake, the most common mistake also that people make is not writing anything down. They think that their first answer has to be the right answer. But you don't have to get it right at first, you have to get it right at last. So there's no reason not to just sketch things out and then dismiss ones that don't work. So we're going to start putting some pieces together. We know we've got an ethyl group. And we know that we've got a methyl group. Let's put those together. Now, of course, this fills the valence of all of the atoms in that structure, so I don't have any room now for the hydroxyl group or this proton. So I'm going to dismiss that. Likewise, we're not going to be able to attach, say, our ethyl group or our methyl group to that OH, because then we also don't have room for any other species, and so those can't be structures. So we know we have to have something in the middle on which we can attach some things, and we remember that we saw in IR that one of these two things is probably a feature. So we'll see that we have the same kind of problem with that nitrile, because if we put it in there, then we're also done with the molecule, so I can't do anything simple like that. I could start thinking about putting something in the middle, something that I don't yet have in any of my structural features. So let's try something like that. So I could take my ethyl group, maybe attach it to a carbon. That carbon maybe has a nitrile on it, and maybe it has a hydroxyl group on it. I know that's a structural feature, and maybe it's got a hydrogen on it. Well, that can't be it, because then this hydrogen would be split by these hydrogens, and it's not, nor are these hydrogens split by this hydrogen. And of course, I also have not included my methyl group, so that's not going to be quite enough either. So let's try this C triple bond C feature. So let's work off that, and maybe on this side I can put my ethyl group. Okay, and then maybe on this side I can put my methyl group. Well, that leaves me with no other attachment points, so that's no good. So I'm going to incorporate again another carbon into the structure, and so let's start with our ethyl group again, and then maybe the carbon that I'm going to put in the middle, maybe an OH here, maybe a methyl here, maybe a C triple bond C here, and then that leaves me with space for that H. Alright, so have I included everything? Well, I have my hydroxyl group, there it is. It's not split by anything. I have my extra hydrogen, there it is. It wouldn't be split by anything, and the chemical shift would be around 2.5. I have my methyl group, and the chemical shift for that methyl group should be a little bit above 1. Well, there it is, that's my singlet. And then I have my ethyl group, and the chemical shifts for those features are also in the correct place. So this looks like a pretty good candidate. So let's check some of the other features. If you look at the IR, it has my triple bond. It has my hydroxyl group. That's good. And if you go up and check the molecular weight, you're going to find that the molecular weight of this is 98. So I like it. That's my answer. If you want to, you can verify some of the information back in your mass spec. This is not 100% necessary, but it's something that you can do. And what you'll notice here is that there's a peak at 83, and 98 minus 83 is 15. That's a methyl group. And this is 69, and 98 minus 69, that's 29. 29 is an ethyl group. So the fragments that are commonly lost do match the structure.